Hey guys, welcome to your online lab number 5. I'm going to set it up again. It's another distillation, but as you might be able to see, today we're using something called a fractional distillation column. You'll see it a little more once I have it all set up, but compared to the simple distillation of last week, we have a much longer column and it's full of these glass beads. And I'll talk a little bit more about that once I get this whole experiment set up. Again, I have to use this kit here and set up your distillation. So, give me a minute to set that up and I'll be right back with the experiment. Okay, so now that I have most of the setup done, I need to actually set up or hook up the experiment. So first thing I'll do is add the round bottom flask with the sample in it. Now, to the round bottom flask, I have added some anti-bumping granules. This will help it boil a little more evenly for our experiment. And in here, I will place 50 milliliters, which I've measured in a graduated cylinder. This is a mixed hydrocarbon, into this, and then connect it to my fractional distillation column. So I'll carefully pour all of this in. Okay, attach it to my fractional distillation column. I will raise the heat source. Turn the water on. Okay, so I'm going to turn the water on here. I have to keep an eye on the water because it tends to kind of leak in the back. Water's on. The heat isn't on yet. But what I have done is I've set up my vernier probe with the lab quest. I've set it to record for about 60 minutes. So I'll put this into the top. Okay, so the probe is sitting here where it will measure the temperature of the vapor just as it's about to condense. I will hit play and turn the heating mantle on to about 5 or 6. And now we wait. As we're waiting for the temperature to rise and then reach our first boiling point, this is again the exact same experiment in theory as our lab number 3, a simple distillation. The difference is this here, the fractionating distillation column. It's a much longer column. You can see the height. I think last week, if you can remember, it was only a few centimeters or maybe 2 inches. And in the column, it's full of glass beads, which I showed you at the beginning. So the idea for a fractional distillation column is it provides more pure product. The product we will be collecting over here in this round bottom flask, and we'll look at our products at the end of this experiment. So the idea is, because the distance the gas has to travel is greater, also because there's so much surface area in this with all of the glass beads, and the column itself has little kind of like indents in it as well. I don't know if you can see that. The surface area in this column is much, much greater than in a simple distillation. So the idea is the gas will condense and then evaporate and condense and evaporate multiple times. So this takes a little bit longer than the other distillation. But by doing that, it ensures that the vapor that reaches here is the most pure product as possible. So that when the vapor reaches here, it will, like I mentioned in last week's lab, condense in my condenser tube for me to collect over here. But again, the idea is as the gas rises, it's condensing and evaporating, condensing, evaporating over and over. And as that happens so many times, it ensures that the product up here is more pure. So fractional distillation gives us a more pure product. One problem that we could see with this experiment, though, is we might lose some of our product, because some of the product will be collected or trapped around in between on top of these beads. There's a lot more surface area here for our initial substance to be trapped in, so we might not get as high of a yield as much of our product, but it will be more pure because of this column. So this is something you need to consider for this course, for your final exam, for the labs even. The difference between a simple distillation, like we did in Lab 3, and a fractional distillation, which we are doing now in Lab 5. So there's not much else for me to say. I'll be hanging around, and when something happens with the graph, I'll be back with the camera. Okay, I just wanted to show you this. It's boiling very rapidly, and I don't know if you can see it, but you can see the liquid condensing in between the beads. And like, I know it's hard, I'm using a cell phone camera, but it's about right here, and it will continue to rise and rise and rise, and eventually it will get up to here. Oops. And then we'll collect our first sample over here. This is a mixture of 2 hydrocarbons. I won't tell you what they are, but they have very different boiling points. So it should be interesting to see how this works. Okay, back again. You can really see the vapor now. It's up at the top. You can even, yep, it's just at the tip of that probe. See it right there? So eventually, I can see some getting in here, and in a minute or two, we might see some drops over here. Alright, I just caught maybe the first drop. Now, this is happening way too fast, so I want maybe a drop every couple of seconds, but it's okay, it's only the beginning. I know I haven't boiled all the way component A, for example, so I'm going to turn the heat down, and we'll wait. And now we'll look at our graph. You can see the graph has skyrocketed up to about 67.2 for right now. That we won't keep that number, we'll see what happens, but the graph should start to level out now. So I'll be back in maybe 5-10 minutes and we'll have a look at the graph. Remember, the minute that this graph begins to rise again, I need to immediately swap my round bottom flask because I'm not collecting the component again. Okay, so I'll be back. Okay guys, so I swapped out the round bottom flasks. This is my first sample here. And the reason I swapped it out is because if you look at this graph here, it started to rise again. Now, when this graph levels out again, what I will do is put in my third and final round bottom flask to collect my sample. This, as it's rising, it's collecting a sample maybe in between the two. Could be a mixture of component A and B. So I want to make sure I don't contaminate my pure second product by collecting this part where the graph is rising. You'll notice there's a little dip in the graph at the end. It's because I turned the heat down, I think, a little too low, but you can see a nice flat part on that curve, and I'll tell you the peak temperature once this lab is finished. So again, when the graph levels out for the second time, I'll put in my third and final round bottom flask. So I swapped out my third and final round bottom flask. You can see it's still boiling away in here. You know, remember what I mentioned in Lab 3. We never completely distill this until it's dry. We always leave a little bit of liquid left in the round bottom flask here for safety reasons. If you distill it until it's dry, the round bottom flask here can crack and cause some very serious problems. So everything's looking fine. My graph is looking pretty good. Right, I get another really nice peak up there. It's about 105 right now. I think it's kind of bouncing up and down because the hot plate is struggling to keep it as hot as it should be. But I'm pretty happy with this graph. All right, so we'll look at the data after. That'll be basically the last part of this lab. So just one more cut. My experiment is finished. Letting things kind of cool down before I collect it. It's still boiling a little bit down there, but let's have a look at the results. So what I'm going to do, I have a beautiful looking graph here. I have you know, the initial temperature where it was room temperature, the rapid rise to the first boiling point, then a little less of a rapid rise to the second boiling point. Remember, this flat part, the temperature, is the boiling point of our first hydrocarbon, and this flat part would be the boiling point of our second hydrocarbon. So what I'm going to do is I'm going to select these three dots here from our flat part of our curve, and I'm going to take the statistics and try to get the average temperature. And you can see the mean here. Mean meaning average is 69.2. So, you know, on average from this graph, about 69.2 is the boiling point of our first hydrocarbon. Okay, let's look at the second hydrocarbon. So I'll select, this is a little bit more flat, so I'll go analyze again. Statistics, I'm gonna have to do this twice. Okay, so the average, the mean for the second one is 105.1. All right, so there we go. I'll make sure to put this graph in your D2L for you guys to reference in your quiz anyways. But other than that, that's the experiment. There's only one part left to do. I'm going to analyze or look at my yields. Okay, so I'll be right back. Well, I've collected all of the yields and I've numbered them 1, 2, 3, and 4. You can see them here. I've put them in graduated cylinders. So number 1, this is our first hydrocarbon, the first we collected. Number 2 is on the graph where the temperature begins to rise again, kind of in between 1 and 3. 3 being our second hydrocarbon. So 2 is that area in the graph where the temperature was increasing to the second flat part, and I collected it just, you know, to increase our chances of purity. This could possibly be a mixture of 1 and 3. 4 is what was left in the flask when I finished the experiment. So I'll take a photo of this so you guys can actually, you know, maybe use some of these volumes. But the question I'll ask, or the question you will be asked is, will all of these add up to 50? The initial amount that I put in was 50. And why or why not? But I'll leave that for your questions in your lab. So guys, that's it. That's your last online lab. The next 2 labs will be in campus because we don't need the fume hoods or anything. So good luck. I hope you had a little fun.